Station, this is Houston. Are you ready for the event?
And the station is ready for the event.
Houston ACR, this is Mission Control Houston. Please call station for a voice check.
Station, this is Houston ACR. How do you hear me?
The International Space Station has you loud and clear, Houston. How us?
Hi, I'm Ken Bowersox, Deputy Associate Administrator for NASA's Human Exploration and Operations Mission Director. This year, NASA's Office of STEM Engagement is hosting the Artemis Student Challenges, in which students from middle through graduate school will be introduced to topics and technologies critical to the success of the agency's Artemis missions. The directorate I work in at NASA is focused on these missions, including sending the first woman and next man to the lunar surface by 2024. Together with the Office of STEM Engagement, we want to encourage the next generation of explorers who will take us further than ever before, the Artemis generation. We're excited to have some of the participants of this year's Artemis Student Challenges and possibly the future of NASA's workforce with us today as they speak to NASA astronaut Bob Behnken, who joins us live from the International Space Station. So let's begin with our first question.
Hi, my name is Swati from Columbia University, and I participated in MyProG Next. My question is, Artemis is the Apollo of our generation. So what advice do you have for college students looking to contribute to the success of space exploration?
Well, that's a wonderful question. What advice would I, as an astronaut living right now on board the International Space Station, give to those who are interested in the next big program, the Artemis program, and going further and beyond where we are right now in low Earth orbit? Is to follow your dreams. You know, when I was young, I didn't necessarily believe for sure that I would become an astronaut one day or have a small part in the human exploration program, but I followed my dreams and I was able to achieve what I've achieved so far, and it's just been a wonderful experience. And so follow your dreams.
My name is Ashley, and I'm from the Liceo Científicos NASA Human Exploration Rover Challenge team from the Dominican Republic. My question is, what safety measures is NASA considering to minimize the biological effects of ionizing radiation that astronauts are exposed to on long-duration interplanetary manned missions?
That's another great question, and it's one that we'll have to continue to explore as we work further away from the Earth. As you know, the Earth's Van Allen belts, the magnetic field that is around the Earth, actually protects the astronauts that are here on the International Space Station because we are close enough to Earth. As we go further out to the moon and we go out to Mars, we'll need to have better protections in place because we won't be able to rely on the protection that Earth naturally provides for us. NASA has a facility in Upton, New York that's doing an extensive ground survey or ground set of experiments to really understand what those radiation effects will be. In the future, I'm sure there'll be pharmaceuticals, exercise, and of course shielding that will be required for our crews as they continue further out.
Hi, my name is Thomas Matterday, and I attend the University of Massachusetts, Boston. I also participated in NASA's Suits Challenge. My question is, in recent years, augmented reality, AR, has become a more widely used tool, and NASA has plans to implement HMDs, such as the Microsoft HoloLens, for use in space. What kinds of extravehicular tasks do you think would benefit from AR assistance?
You know, as it is right now, astronauts that prepare for spacewalks, even on board the International Space Station, use a virtual reality experience at the Johnson Space Center in order to better prepare them for the spacewalks. There are many aspects of that virtual reality that become very useful for us. One is flying the little rescue pack that we carry on board ourselves in case we were to get too far away from space station, become untethered, and need to fly back. In order to practice those skills of flying that rescue pack, we use the virtual reality facility. I think as we continue to go forward, having a vision augmented system that allows the ground team to see what the astronaut is viewing and really give very specific directions and point out as to which bolt or which lever or which particular piece of equipment to grab or turn or twist or pull is going to be very helpful. As you might imagine, some of our environment is very complex. If you look around on board the International Space Station, you'll see a lot of places that are very complex, and if we had a specialist who could give us a good point out, we would definitely love to have that help as we go through and do more complex tasks.
Hi, my name is Michael from Nwetehidatsa College on the Fort Berthold Indian Reservation. I participate in First Nations launch. My question is this. Several countries and now commercial entities have launched astronauts into space. How does it feel to be a part of human history as interest in space travel are reignited?
Thank you, Michael. You know, as one of the first crew members who had the opportunity to fly on board a commercial vehicle headed into low Earth orbit, I was really proud to be a part of that. I was also extremely proud to be a part of bringing human spaceflight back to the United States. That was something that was important to me as an astronaut and something that I'm really glad I was able to see. As an individual, I really do look forward to the day where a lot more people are able to join us in low Earth orbit and really understand the work that we do up here and the level of cooperation that it takes to pull off something as magnificent as the International Space Station. Projects that will continue further out to the moon or to Mars, like Artemis, are going to require that level of cooperation to be successful.
Hi, my name is Charlie, and I'm on the Oak Park High School student launch team. Our question is from a press conference in 1969, just prior to the Apollo 11 mission. Neil Armstrong was asked what he would like to bring to the moon, but couldn't. He responded, probably a little extra fuel. We'd like to ask you the same question.
I think Neil speaks for a lot of us with a very practical answer to such a question. Anything that you could have that provide you a better chance of success is what you want to bring as an astronaut, because you want to bring your best to the game, and that means bringing all the possible things that you might need. Of course, some luxury items are also important, and for me, bringing something that reminded me of my family was very important. And as you can see, our zero-G indicator from Dragon that Doug and I brought with us is a toy from our sons. And so trimmer didn't weigh very much, and so the amount of fuel that we could have wouldn't have made much of a difference, and it is really nice to have something from home with us.
Hi, my name is Najia from the University of Baltimore, and I participate in NASA Suits. My question is, what are the most important lessons you have learned through your current missions, and how can these lessons be applied to preparations for the Artemis mission?
That's a really good question, and I think the most important lesson that every astronaut would share with you is the importance of being prepared. And so there's an old adage that fortune favors the prepared, and I think that's really true for us. And so the entire NASA team goes through extensive efforts to really make sure we've thought of all the things that could happen and really make sure we have a plan or the appropriate equipment to respond to them. And so that fortune favors the prepared is one that Doug and I used coming uphill on Dragon as we prepared for that test flight. We really wanted to make sure that we had everything that we needed and we had thought of all the contingencies. And so hopefully we've got them all covered on the entry side as well when we go home.
Hi, my name is Josh. I'm a student from Northern Arizona University, participating in First Nations Launch SpaceX team. My question is from an engineering perspective. What significant enhancements have improved space travel from rocket launch to docking at the space station?
Josh, I really like your question, and one of the things that I've been able to see as an astronaut is the transition from where we were with the space shuttle to where we are with the new commercial vehicles. The amount of capability that computers have brought to the the vehicles has really been impressive, and that allows the astronauts to focus on the entire big picture of the mission rather than focus on needing to do the work that the computer does just naturally better, whether that's computing orbital trajectories or the duration of burns as you maneuver around and try to get to the location that you're targeting. Rather than having to do that all manually, the level of automation really allows the astronaut to think of the big picture of getting docked, what we'll do during the mission, rather than really focusing on just the nuts and bolts of even being able to take step one. We can think in groups of 100 steps. It's kind of the difference between having a smartphone and having a rotary dial phone, just in terms of what capability you have.
Hi, I'm Carrie, and I'm from Lone Star College Sci-Fair, and I participate in Micro G Next. My question is, how important are student contributions to NASA, such as the zip tie cutter designed by a previous Micro G Next team from my college, and that Luca and Drew used on the first 2 AMS EVAs?
Hello, Carrie. It's a wonderful question, and I think that probably the most important aspect of that project, the zip tie cutter that was used for the AMS activities, is that the teams on the ground, a relatively junior team from an engineering perspective, was able to focus on a problem that needed to be solved and come up with an innovative solution. On board the International Space Station, we have quite a few examples of projects where student teams have come together and developed something for us, whether it's something as simple as the table that we eat at every night, or something as complex as providing hardware to support the repair of a very, very valuable instrument on board the International Space Station during a spacewalk. Just having a team to focus on real concrete objectives and solving real-world problems, I think, is very important to any engineering team, and particularly from an education perspective.
My name is Zach.
My name is Skyla. We're from the Blue Ridge High School Boys and Girls NASA Human Exploration Rover Challenge teams. Sometimes it is the little things in life that make the biggest difference in our future direction and accomplishments.
Our question is, who was the teacher that set you on a trajectory into space, and what did they do or say to set you on this path?
Thank you.
It's a wonderful question, and I think all of us who are on board the International Space Station, or folks who've had successful careers in other professions as well, can really reach back to a specific teacher who made a difference for them. And for me, it was a teacher named Mr. Weisenberg when I was a young grade school student, who always challenged us to kind of think and predict what might happen if we were to do a specific scientific experiment. And so I took his challenges to heart, and each week he would provide us an opportunity to test something and predict what was going to happen. And if somebody else wasn't prepared, I had always had an extra experiment kind of in my desk ready to go to try to demonstrate some new physical phenomenon that I had read about or he had shared with us earlier in the week. And so I'd like to thank Mr. Weisenberg for doing that as a grade school student. It was very important for me.
Hi, my name is Andrew, and I'm from Piedmont, Virginia Community College's NASA Student Launch Team. My question is, many of the skills that you've learned as an engineer and a test pilot are clearly useful for spaceflight, but what less obvious skills have you found to be unexpectedly useful as an astronaut?
Andrew, I really like your question. It kind of leads to something that maybe isn't what's expected normally for scientists, engineers, or test pilots or military officers like myself to talk about. We don't talk a lot about the need from a self-care perspective and kind of recognizing in challenging situations the things that we need to do to best be prepared. whether that's getting enough sleep or being well hydrated. Those are pretty basic fundamental pieces of the puzzle. When you're in space for a longer period of time, or when you're under extremely stressful situations like a rocket launch, or maybe for some folks going out on a spacewalk, recognizing the emotions that you're going to go through and having a plan to be prepared for those is very important. And so I would say that's a personal, mental self-care, recognizing things that are challenging for you, things that are stressful for you, and figure out how you're going to manage to work around that. Do you need to practice extra? Maybe that's what works for you. Do you need to talk with a friend about things? If that's something that works for you, then go and do it. And so I think recognizing what you need to be as successful as possible from all perspectives. The easy ones are the food and water sort of a category, or some basic training. The more complex one are how you're going to feel in some of the more challenging situations you might face, or for a long period of time, like you might be on the International Space Station, making sure you've taken good care of yourself.
Hi, my name is Nate from Northview High School in Ohio, and I participated in the student launch. My question for you is there any differences in training astronauts receive when preparing for the moon versus preparing for Mars?
It's a really good question about what we would do from a training perspective to prepare differently if we were going to a location other than the International Space Station, going to the moon, or going on to Mars. The level of preparation will be extensive for those crews. Understanding the mission that's in front of them will be important. One of the challenges that they will face that we don't necessarily face is that the ground is always available to us almost instantaneously. Very often I can do things like reach out and call my family, for example, in addition to, of course, talking to the mission control team. For missions that are further away and that may have different pathways that the communication stream takes to get back to Earth and get back to the team, being able to operate for extensive periods without assistance, that more autonomous approach, if you will, is going to be critical for our ability to continue to operate. We often have questions during the day up here, and it's just not going to be practical to be able to ask those questions or stand by and wait for an answer with the level of work that needs to be done as we prepare for missions further out.
My name is Wiesem from Purdue's Rover Challenge team. NASA is opening up the ISS to private astronauts. SpaceX has already teamed up with Axiom Space to launch a team of 4, and NASA is working with Tom Cruise on a film aboard the ISS. My question is, how would you feel working side by side with private astronauts, and how would it affect the work environment on board the ISS?
We've been asked that question several times over the last few weeks, the question of how would we feel about working with other astronauts that aren't necessarily from a government, whether they're private or corporate, that would be with us on board the International Space Station. I think the specific question that came up previously was about spacewalks, and I think both Chris Cassidy and I answered it very specifically, which is that we would be comfortable with working with those teams and look forward to those opportunities, and we're really confident that the teams that prepare them to come into orbit are going to prepare them with the appropriate training to make them really similar to us in terms of a level of preparation, in terms of how they would respond, whether it's from an emergency perspective or from handling the operation of an experiment. You know, there is a common culture that we'll work together and be prepared to go forward with, and it will be a truly exciting time because it will be a new experience as we teach other people who will live and work in space with us how to do so, or how we've done it, and maybe share our experiences with them to make them learn even faster than we did when we got here.
Hi, my name is Leah from the University of Pittsburgh, and my team and I participate in Student Launch. My question is, if you could change or add anything to the space station, what would it be and why?
Well, thank you, Leah. I like your question as to what would I change about the International Space Station. And I think my preference would be to add a few more windows add some locations that aren't quite as challenging from a lighting perspective to observe the Earth or to observe other things happening outside, or even potentially keep them open when we have visiting vehicles arriving. We try to protect our windows, and there aren't very many of them on board the International Space Station. And so that look of the Earth and taking the opportunity a few minutes a day to do so, I think, is one of the things that energizes all the folks on board. And I think as astronauts go forward deeper into space, it's going to be really critical to provide them that connection with the outside world rather than simply inside of a closed container. And so more windows is what I would ask for.
Hi, I'm Tanisha Dixon, NASA Education Specialist and Manager of NASA's Micro-G Next Challenge. Thank you for taking time to speak with the participants of Artemis Student Challenges today.
I'm sorry, I'm going to have to ask for that question to be repeated. I couldn't quite understand it.
Station, this is Houston ACR. The closing remarks were from Tanisha Dixon, NASA Education Specialist and Manager of NASA's Micro-G Next Challenge. She said, "Thank you for taking the time to speak with participants from the Artemis Student Challenges today."
Well, thank you for the opportunity to participate in such a glorious event. I really do think it's important for students of all ages to face the challenges of trying to produce something that solves a real-world problem. And our space challenges as we move forward for deeper exploration really provide that opportunity. We have plenty of experiments or equipment on board the International Space Station that student teams have developed, and I look forward to seeing what ideas come next.
Station, this is Houston ACR. That concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station. Thank you.
And thank you to all participants from the Artemis Student Challenge. Station, we're now resuming operational comm.